So by forwarding the operand from the output of the execution stage to the input of the execution stage, we overlapped both these instructions without causing any data hazard and without stalling the pipeline. Now suppose there is one more instruction which is also dependent on the same register R1. In the third cycle, when our fetch unit is free, we will be able to fetch this instruction. But in the fourth cycle, if we try to decode this instruction in the decode stage, according to this MIPS pipeline architecture, operands are accessed from the register. Hence, operands are accessed from the registers R1 and R7, but our required data is not available within the register R1. It will be available or it will be written to register R1 only at the end of the fifth clock cycle. Thus here there is a chance for data hazard, and here the problem occurs because we are trying to access some data from the register file and that data is not available within the register. Now can we use operand forwarding whether that data is available somewhere within the pipeline? This instruction needs that data for execution, hence it needs the data at least at the beginning of the execution stage or at the end of the decode stage. When I3 is at the end of the decode stage, instruction I1 which produces the data is at the end of the memory stage. And that required data, which is the sum of the content of R2 and R3, is already computed by I1 in the third clock cycle in the execution stage itself, and that data is available with I1 now in the fourth cycle in the memory stage. Now in the fourth cycle, I1 is in the memory stage with the data and I3 is in the decode stage. Now in the next clock cycle, when I1 moves to the write back stage and when I3 moves to the execution stage, if this data can be forwarded to the input of the execution stage, then I3 can make use of this data for its execution and the instruction can be processed out in the next clock cycle itself. Means in cycle 1 we fetch I1. In cycle 2 I1 is in the decode stage, I2 in the fetch stage. In the third clock cycle I1 is executed, I2 is being decoded and I3 is being fetched. Now the required data, the sum of the content of R2 and R3 is computed by I1 in the execution stage. In the next cycle I1 moves to the memory stage with that data. I2 is being executed, I3 is being decoded, and I4 let some other instruction which is not dependent on all these can be fetched. Now I3 is being decoded and I1 is having that data. So in the next clock cycle, when I1 moves to the write back stage and I3 moves to the execution stage, if this data can be forwarded from the output of the memory stage to the input of the execution stage. In the fifth cycle, when I3 is in the execution unit, can make use of this data for its execution. So here we forwarded the data from the output of the memory stage to the input of the execution stage. So the general idea is we try to access the data from the register file in the decode stage. If the data is available, then it's fine. Otherwise, if the data is available somewhere within the pipeline, forward it to where it is needed. In both these cases, data is needed for execution, so we forwarded it to the input of the ALU stage. Suppose the data is needed at least at the beginning of the memory stage. For example, for a store instruction, the data will be needed at least at the beginning of the memory stage. In such case, we can forward it to the input of the memory stage as well.